Hello and welcome back to my channel. Today in this video we are going to discuss the solution of Cambridge International AS in A-Level Mathematics paper 6, that is Probability and Statistics 2, and it is from March 2021 and the component in code is 970962. So let's start with the question number 1. And here's the question number 1. A construction company notes the time T days that it takes to build each house of a certain design. The results for a random sample of 60 such houses are summarized as follows. Sigma of T is 4820, sigma of T square is 392,050. A part is to calculate a 98% confidence interval for the population mean time. So we are going to find the confidence interval for the population mean time, and it is not a normal, and we can see the sample size is 60, which is more than 30. So it means by CLT it is going to, the population mean is going to be approximately normal. So the population mean for 98% confidence interval, first of all let me draw the normal scenario. What is the meaning of 98% confidence interval? Yeah, here's the normal distribution curve, and if it is 98%, let's say it is 98% confidence interval, this is the interval 98% confidence interval, and hence we have 1% left here and 1% is here, so that it will make it 100%. So we require these two boundaries for the 98% confidence interval. So we require the corresponding z value. If we have the z value here, if from the mean, of course in the standard normal distribution it is 0, so 0 to z for 98%, we can see if it is, we take it, we talk about z, it is going to be a complete this, and this is going to be 99%, 98 plus 1, 99%. So this is total 99%. And corresponding to 99%, the z value is going to be 2.326. It is from the distribution table. We can see it is z corresponding to c corresponding to 99%, not minus. It is 99% corresponding to 99%. It is z is 2.326. So the confidence interval, I'll write Ci is going to be x bar plus minus z and the errors, standard errors, sigma over root n. So we require all these, and we can see it is not normal. It means we are going to estimate these two values. It is actually mu. So sigma and mu we require, and we know the estimate for this x bar. It is going to be the estimates, unbiased estimate of population mean mu. It is given as sigma of T over n here, and since we cannot we have not been provided with the sigma, so we are going to calculate the estimate sigma square, and we have the formula for it. It is n over n minus 1 times sigma of T square upon n minus sigma of T over n whole square. That is the unbiased estimates for variance, and this is unbiased estimates for mean, population mean, and hence it is going to be 4820 over 60, and here it is going to be 60 over 59, and this is 392050 over 60 minus this value 4820 over 60 whole square. So let's calculate these two values. So I'll write it as x bar here. X bar is 80.333 and so on, and from here we get unbiased estimates for sigma square, so we write it as s square. So s square is going to be from here, so this value is coming 82.09039, so we can take it as 4. Now we have x bar and s square. So we'll put in this formula. So the confidence interval CI is going to be x bar, that is 80.3333 till 4 decimal place, all right, minus plus minus z is 2.326, and here sigma corresponding to sigma, because we have the unbiased estimate, so we are writing s square. So from here we get sigma as the square root of s square. We are writing the estimates for this, so square root of this, I'll write square root of n as well, so it is going to be 820904 upon 60. So we will calculate this. So lower bound by subtracting and upper bound by adding, so it is going to be 77.6126 and so on. And if we add, so that is going to give us the interval 0, 5, 4 and so on here as well. So confidence interval 98% confidence interval is going to be till 3 significant figure. We'll write our answer 77.6 comma 83.1, and that's the confidence interval, 98% confidence interval. I hope it is clear. Let's discuss the next part. Here's the B part. Explain why it was necessary to use CLT, central limit theorem, in part A. So this type of question always carry 1 mark, and we have a definite answer for it. If we are using the CLT, that is central limit theorem, it means the population distribution is not normal, and if it is normal, there is no need of using central limit theorem. So we will write because population distribution, and here it was time, so population distribution time is not normal, or we can say is not known. Both are, is not normal or known, or we can say it's time population distribution is unknown or not normal. Here's the second question. The diagram shows the graph of the probability density function f of a random variable x. Find the value of constant k. So since it is a PDF, this is a PDF, we can see this by bold graph, we can see. So if it is a PDF, it means we know the area, that is of course the probability, the total probability is 1, so we are going to use that property. So the area or total area, because here we can see the total area is just the area of triangle, so area should be 1. It means area of triangle is 1, or we can say half of base into height is half k, should be 1. And from here we get k square, will cross multiply, will get 2 into 2 4. So from here we got k as plus minus 2. Of course it cannot be 2 because it is given that it is positive side, so k value is 2. So that's the value of constant k. And here's the B part of it. Using this value of k, means k is 2, find fx for 0 to k, means from this point to this fx, and hence find expectation of x. So this represents fx, otherwise it is 0. We can see this is 0, this is 0, before 0 is 0 and after k it is 0. So we require fx, and here fx is a line, and this line is fx is a straight line passing through, we can see this coordinate is going to be k comma 0, and this coordinates are going to be 0 comma half k. Passing through one point, we can take k0, k is 2, so it is 2 comma 0, and another is 0 comma half k, that is 0 comma 2 by 2, that is 1. So the equation of line, we can take fx as y. So y minus y1, we can take 0 as y1, as equals y2 minus y1, 1 minus 0 over x2 minus x1, 0 minus 2 times x minus x1, x1 is 2. So this become y equals minus half times x minus 2, or we can say fx is, we can simplify the right hand side, it is half x minus minus plus, and 2 by 2 cancel, that is 1. So that is the fx for x between 0 and k, or 0 and 2. Now we will calculate expectation of x. So expectation, we know expectation of x is, in the discrete distribution, it is always going to be x sigma of x fx, and here it is continuous distribution, so it is going to be integration from minus infinity to infinity x fx dx. And we know from minus infinity to 0 it is 0, so we can simply start with the starting limit can be 0, and we know after k, that is after 2, it is again 0, fx is 0, so ultimately x into fx is going to be 0, so the upper limit can be 2. And in this region we have just seen that the function is fx is half x minus half x plus 1, so it is going to be minus half x plus 1 dx, or we can say it is going to be, again I'll write 0 to 2 minus 1 by 2 x square plus x dx, that is minus 1 by 2 x square, integration is going to be x cube over 3 plus x integration is x square over 2, and the limit from 0 to 2, and this is going to be half minus 1 by 6, sorry, 1 by 6, and upper limit is 2, so 2 into 2 into 2 cube is 8 plus x square by 2, that is 2 square by 2 is 4 by 2, minus lower limit is going to be 0 because everywhere x, so it is going to be 0 ultimately, and we'll solve it. It is going to be minus 8 by we'll simplify, 2 3s are 6, 2 4s are 8, and this is going to be 2, so minus 4 over 3 plus 2, 3 2s are 6, minus 4 is 2 by 3, and that's the expectation. That's the expectation of x. I hope it is clear. Let's discuss the next one now. Here's the C part. Find the value of p such that probability of x between p and 1 is 0.25. We know from 0 to 2 it is right, fx is minus 1 by 2 x plus 1 in 0 to 2, so p is of course going to be something more than 0 and less than 1, so fx will work in this. So now we are going to convert this into the integration form, because we know the probability we write in this form. The two values are going to be the limits p to 1, fx dx is going to be 0.25, and 0.25 we can write it as 1 over 4. So integration would be integration of this, that is going to be minus x square upon 4 plus x limits from p to 1, and it is going to be 1 over 4. So after putting the limits we get minus x, upper limit is 1, so it is going to be minus 1 square, it is minus 1 over 4 plus 1, and minus lower limit, so minus minus it become plus, x square means p square over 4 minus x means minus p is going to be 1 over 4. So let's bring everything one side. We get it as, I'll do it here, it is minus 1 by 4 and it is 1, so 4 minus 1 minus 3 by 4 is going to be, sorry, it is plus 3 by 4, and this 1 by 4 will be minus 1 by 4 here, plus p square over 4 minus p is going to be 0. So ultimately we got here it as 2 by 4. 2 by 4 we can cancel, but it's not required because we are going to remove 4 from denominator. P square by 4 minus p equals 0. So we have denominator everywhere 4, so we multiply by 4 everywhere, we get 2 plus p square minus 4p. 4p equals 0. So we can make a quadratic equation in p, the standard form. P square minus 4p plus 2 equals 0. We can see we cannot use a splitting middle term, so we are going to use the quadratic formula to find the value of p, and p is going to be minus b, that is plus 4 plus minus root b square 16 minus 4 to the 8, so minus 8 over 2a, that is 2, so it become 4 plus minus 16 minus 8 is 8, and 8 is 2 root 2 over 2, so we got it as 2 plus minus root 2. And we know if we take if we take plus, this p is going to be more than 2, which is of course not possible, so we have to take minus sign. So it is going to be, possible value of p would be 2 minus root 2. So we can write our answer in this way also, or we can calculate 2 minus root 2. It is going to be p equals 0.5857, so we can write 0.586 till 3 significant figure. So that's the value of p. I hope it was clear. Let's discuss the third question now. Here's the third question. An architect wishes to investigate whether the buildings in a certain city are higher on average than buildings in other cities. So that's the key word, than buildings in other city, on average, higher. These are the key terms. He takes a large random sample of buildings from the city and finds the mean height. So again, he takes a large random sample of buildings and finds the mean height. It means it is going to be normal because of CLT of the buildings in the sample. He calculates the value of the test statistic z and finds that z is 2.41. So once it is approximately normal, he has calculated already the value test statistics, that is z, it is 2.41. A part is explain briefly whether he should use a one-tail test or a two-tail test. So we can see from here that he is going to investigate whether the buildings are higher on average. So it is of course going to be one tail. One tail, as architect is investigating for higher or increase. So that's the condition explanation, we can say. B part, carry out the test at 1% significance level. So in case of 1% significance level, we are going to test it. It means we are going to test the mean, because in the case of normal distribution we talk about the mean, and here they are talking about the mean height of the buildings in the sample. So of course the significance level, when we start our test, we write the two things. One is null hypothesis and another is alternate hypothesis. So null hypothesis would be here the population mean, or we can say mean height, or yeah, population mean would be fine, or we can use mu here. Mu is same. You see he is checking, or architect is checking for whether it is on average the building is higher or in buildings in the other city. So it is going to, mu is going to be it is same. The null hypothesis is mu is same as other buildings, and or we can write simply others, and here mean is mean height, so this is same as others. And alternate hypothesis is mu is more or higher than others. So these are the two conditions we can say, the hypothesis H0 and H1. Now we will reject H0 if this is we know that if it is coming in the rejection region, then we reject the H0. So let's start the comparison. So I'll write the test statistic which architect got. Z was 2.41. that is what architect got. So for 1% significance level, let's talk about 1% significance level, and since architect is searching for higher, so we'll take this as 1%. So if it is 1%, and if here this test statistic is coming in this region, it means it is coming in the rejection region. Find the corresponding Z value. If it is 1%, so corresponding 99%, what is the Z value here? So we know Z value is going to be 2.326. We have seen in the first question also. Z is 2.326, and the test statistics what he got is coming Z as 2.41. So as Z is equals to 2.41 is higher than 2.326, it means reject H0. It is coming, this Z value is coming in the rejection region, so reject H0. Or we can say that there are enough evidence that mu is the height is not same as the other buildings. Or we can talk about the investigation, in the terms of investigation, that there are evidence that mean heights of the building is more. There is enough evidence that on average, because they have written on average the height, or we can say buildings are higher. Why it is buildings are higher? We could have written that reject H0. It means that they are not of the same height, but since he is investigating for higher, so we should give our conclusion line as in the sense of like what the architect or the question is asking. So that's it. I hope it was of some help. So let's discuss the next few questions in the next video. Till then, thank you so much.